Good morning, my dear student. I am Tarun Garg. Today we will discuss about polarization. So before polarization, we will discuss about dipole moment, electric field, and so on. So electric field is what? Electric field is nothing but force per unit charge. And the Colombian force we know about, this is the 1 upon 4 pi epsilon 0 q1 upon q2 by r square. And this is the direction of the force. The electric field lines always originate from positive charge and close or terminate towards minus charges. When two opposite charges separated from r distance. So dipole momentum written is the magnitude of charge and separation between two times the separation between the charges. This is the dipole moment. Actually, how to we define dipole momentum in electric field or dielectric medium or conductors and semiconductors. So first we will discuss about what is conductor, second one is semiconductor and insulator. So all three is the metallic properties. In metals, when the band gap easy towards very less or easy towards zero means so separation between conduction band and valency band, separation between conduction band and valency band is decide the nature of the material, which is conductor, semiconductor or insulator. When this gap is increase, the nature of the material goes to insulator. When this is the separation is decrease and this goes to semiconductor, and when this separation is very close, then it will be conductor. So in this lecture we will see in dielectric medium actually the dielectric medium as non-isotropic we know and non-homogeneous. It means we will see how isotropic and non-homogeneous. So non-isotropic means the material properties different in different direction. But generally we consider the in dielectric medium sometimes homogeneous and isotropic. So what happened when dielectric medium is lie in the electric field? When apply the electric field, what happened in dielectric medium? This like dielectric. In dielectric mediums, nature of materials may be polar and non-polar. So dipole moment of polar and non-polar is different. So for polar molecules, we have seen example of CO2. The negative charges, ions. This is oxygen. This is carbon molecules. This is oxygen. Towards always positive. So net dipole moment of non-polar molecules will be 0. But in case of polar molecules, the dipole momentum is not equal to 0. It is example is H2O. How to H2O? H2O means this hydrogen molecules, this is oxygen. This is example of non-polar molecules. So our aim is when polar molecules and non-polar molecules, polar and non-polar dielectric material inside the capacitance. What is capacity of the condenser or capacitor? When non-polar molecules, dielectric molecules present in the capacitor, and this capacitor connected to the potential difference of battery V. So in non-molecular moles, example of this we have seen this type. The negative ions coincide with positive ions. Negative ions coincide with positive ions. It means the net dipole moment we have seen previously 0. When this coincide, so these molecules are neutral, electrically neutral. So non-polar molecules electrically neutral. When electrically neutral material presence in the capacitors. So what happened? When the potential difference apart from this is the positive ions, this is negative ions. So in the presence of the electric field, the dielectric molecules of negative and positive charges are separated. This is negative ions towards the positive plate of capacitor and positive ions of the non-polar molecules is towards the negative plate of the capacitor. So inside the capacitor, the electric field produce. So due to this electric field, net dipole moment induced in the dielectric material. So net induced dielectric material, sorry, uh, the 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 induced dipole moment in the material is P induced, and the direction of the induced dipole moments always in direction of the applied electric field. So whatever the induced dipole moment is proportional to applied electric field. So we remove the proportionality constant. The induced dipole equals to alpha E external. So alpha is the polarizability constant. Here alpha is polarizability constant, and the dimension and the unit of the polarizability constant found by alpha equals to dipole momentum per unit electric field. So intensity of electric field the ratio to the induced dipole moment to the electric field is the polarizability of the non-polar dielectric molecules. Thank you so much.